Hi everyone, this is Sindhuja Reddy, working as assistant professor in computer science and data science at Marri Laxman Reddy Institute of Technology, Telangana, Dundigal. So today I am going to explain about the compiler design subject. So the compiler design is the most toughest subject, and we are going to explain one by one topic. So we are going to the starting topics, the introduction of compiler design and the phases of compiler. So regarding course objective, the fundamental principles, we need to understand every compiler design and the skills where how we are using the compilers in every situation. In our career, the compiler design is probably it is using in our daily life. So according to the course syllabus, we have the many phases and the structure, how we are using the compiler and how we are using in our daily life, how it is useful for our students. So the first topic in compiler design is the introduction of compiler design. So the introduction of compiler design, first we need to know what is compiler. First, we need to know what is compiler. The compiler is a software that is used to translate the source code into the machine code. So here, what is source code? What is source code? The source code is nothing but it is a human written language. It is a human written language which consists in a high level language, high level language. We are converting it into the low level language. We are converting it to the low level language, which is target node. So the source code is nothing but a human language. The source code is nothing but a human language which consists in high level language, So what are the high level language? The high level language is nothing but a daily life. We are using the programming languages, that is C, C++, Java and Python. And we are converting this high level language into the low level language. We can say it is the intermediate code. We can say it as the intermediate code. So here we are discussing about the introduction. The compiler, it is basically used to compile the programming code. So here we have to know what is the history of compiler, how we are knowing about the compiler in day to day, and years ago we are how it is introduced and how we are using it. It will be appeared here. So the next topic is history of compiler. In the 1950s, Grasshopper developed the first compiler. That first compiler leading to the languages like Fortran in 1957. In 1957 and COBOL in 1959. So this is the first compiler which is used for the programming language. It is introduced in the year 1950. The next year and the 1960, the few innovation they introduced, that is Algol. And 1970 it is introduced the C and the Pascal. After innovation of C and Pascal, it is increased to the different programming languages, that is C++, Java, which we are using in our daily life. So it is mainly focused, the modern compilation, it is mainly focused to optimize the code in a time compilation. It is more easy in our daily life. Nowadays we are using the all types of high level language. It is more easy to compile It is more easy to compile by supporting object-oriented programming languages. Object-oriented programming languages. So that the basic structure of compiler is we have several phases. We have several phases which consist or interconnected with the compilation process. It is interconnected with the compilation process, and each phase consists of a specific responsibilities. Each phase consists of a specific responsibilities and translation process. So mainly we are using in our syllabus and mainly we are using in our subject. The compiler design consists of 6 phases. Here is the phases of compiler. Here is the phases of compiler. Before me moving to the first compiler, that is lexical analyzer, first we need to know, already we discussed that the source language is nothing but it is the human language which is written by the human with the error codes. We need to rectify that error codes by using this all the phases. So the source language, the lexical analyzer, and we are using the more 5 phases. We are rectifying the code. So first, what is source language? The source language is nothing but the human written language which consists of high level programming codes like C, C++ and Java. So the first phase in lexical analyzer. So the first phase of lexical analyzer, it is also known as a scanner. It is also known as a scanner. What is scanner? The scanner, it is used to read character by character. What is the purpose of scanner? The scanner is used to read the characters by one, and it works as a text scanner. We can say as it works as a text scanner. This phase break down the source code into these small pieces. By using this first phase, it is used to break down the source code into the small pieces which are in basic building blocks. We can't say small pieces, we have to say blocks. So which are basic building blocks like keywords, identifiers, operators and punctuations. So here by using the scanner, or here we are using the first phase, that is lexical analyzer. What is the use of it? It is used to scan, or it is used to read the code character by character. By reading this, it has to produce the output as stream of tokens. When we are scanning the text, and it is producing as a tokens. So the first example is int x is equal to 10. The first phase we are using, that is lexical analyzer. In this lexical analyzer, we are taking the example, that is int x is equal to 10. So what is int? All of you know what is int. Int is a data type. According to the first phase, the data type is a, what is data type? Is a identifier. Data type is a keyword. And we can say as a identifier also, but the data types always we can say as a keyword. And the next one, that this keyword, int is a keyword, we can say as a data type. The next one is x. What is x? X is a variable, or we can say as a identifier. Next, is equal to. Equal to is nothing but a assignment operator. Assignment operator. The next one is numeric value. The last, the semicolon, it is a punctuation. Punctuation. So here the basic use of the lexical analyzer is it is used to read the character by character and it produces the output as a token to the next phase. So here the first example, that is int x is equal to 10. Here int is a keyword. We can say as a data type. It is a data type. X is a variable and is equal to is the assignment operator and 10 is a numerical value and the semicolon is a punctuation mark. The next phase, that is syntax analysis. The next phase is syntax analysis. So here the next phase is also called as parser or parsing. Parser or parsing. So this parsing is nothing but it takes the token as input and form in a syntactical manner. In a correct syntactical manner by following all the rules of a program code. And in this parser, it checks the tokenization. What is tokenization? This tokenization is nothing but the parser checks if the expression made by the token in syntactical is correct or not. So the syntactical analysis is nothing but it is known as a parser and it takes the input from the first phase lexical analyzer as tokens and it will arrange the tokens in a systematic way according to the language of program code and it will verify the program code which is used as the expressions made by the tokens, it is correct or syntactically it is correct or not. So in this syntax it will be checked or it will be represent in a hierarchical structure. It will represent the code of the parser or token in a hierarchical structure. So what is the hierarchical structure? That hierarchical structure contains from parent node to child nodes. For example, we are taking E tends to E plus T. Next T tends to T plus F. F tends to 60. So first we need to write the parent node, that is always the terminal, that is the capital letter, and we are giving the child nodes, that is E plus T. Always the capital letters are the parent node. Again we need to write the T. In the place of T we have the T plus F. So here we need to substitute T plus F. And in the place of F we have the variable, that is variable or numeric value, that is 60. So the child node always we have to be non-terminals. The parent node should be terminals. Non-terminals. So the basic points we need to remember in syntax analysis is the syntax analysis is also known as the parsing and it takes the input from the first phase, that is lexical analyzer, and it produces the tokens in the form of hierarchical structure, that is parse tree, and it checks the program or sequence of sentences in a systematical manner it arranges the systematical manner and it checks the expressions, the syntactical way it is correct or not. The next phase, that is semantic analysis. The next phase, it is semantic analysis. What is semantic analysis? It checks whether the parse tree which is producing the as a parse tree, it checks the rules of the language. It ensures the programming logic makes a sense. They write without any errors, and it uses the semantic analysis. It uses the type checking or undeclared variables are there or not, it will check. Mainly the semantic analysis, it is used to take the input from the parse tree and it will check, it contains any error in the code, by using type checking. If by using type checking, it uses type mismatches or declared variables are there or not. After verifying it, it will send the source code to the next phase, that is intermediate code generation. So this intermediate code generation, it takes the input from the semantic analysis. Semantic analysis. The compiler generates the intermediate code between the source code and the target machine. It represents the source code of a target machine. It represents the program from abstract machine, and it is between the high level language and the low level language. And the intermediate code, it will create easier way to convert, or it is easier to translate to the target machine code. So semantic analysis, which is analyzed or check the errors, it will send to the next phase, that is proper parse tree. The intermediate code generates the target code, and it plays the mediator between source code and the target code. It takes from the abstract machine. The next phase is code optimization. So, code optimization already we discussed, every phase has its specific responsibility. So, here the code optimization, it takes the input from the intermediate code which is sent through abstract machine. So this optimization, it makes sure unnecessary code obtained in the parse code or not. It will check it contains any unnecessary code, white spaces and empty lines. It will erase all the unnecessary fields, unnecessary codes which is in the parse tree, and arranged in a proper syntactical way. Proper statements or syntactical way in a proper arrangement to increase the speed of the compilation and its efficiency. So what is the purpose of code optimization? This code optimization takes the input from the intermediate code which is assigning by using abstract machine, and it checks what is the code contains any white spaces, any unnecessary lines, any gaps between the lines. It will erase all the unnecessary code, and it will arrange the statements in a order. And send to the next phrase by increasing its execution time. We can say execution of program code time, we also say. The next one is code generation. After this, in the code generation is the last phase which is used used in the phases of compiler. Code generation, it takes the input from the code optimizer, which is arranged in a order, in a optimized representation of the intermediate code. And what is the work of this code generation? It has to map to the target mission code. This code generator is used to execute the program without any error. So these are the phases of compiler. We have 6 phases, that is lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. So lexical analyzer, it produces the token and send to the next phase. In syntax, what is the purpose of syntax? It is also known as a parser, and it will send the hierarchical structure to the parse tree in a syntactical, without any syntactical error. And whenever the semantic it receives the parse tree, it checks the program code is syntactical it is correct or not, and again it's sent to the intermediate code generator. It plays a important role between the high level language and low level language, and it uses the abstract machine to send the data to the next phase, that is code optimizer. What is the purpose of code optimizer? The code optimizer should remove the new spaces and unnecessary lines, and those all things it should be removed, and it has to make all the statements in a order and send to the next phase, that is code generation. The code generation, it is used to optimize the code, and it arrange or map to the target machine language to get the output without any error. So the last one, we have the symbol table. The symbol table is nothing but it is a data structure maintain all the phases of compiler, or maintain or store all the phases of compilers, identifiers, and these types are should be the storage. We can say the symbol table, it is the storage unit. It is the storage unit of all the phases of compiler. In all the phases of compiler, in we can say that symbol table we can say as the storage, and it stores all the identifiers, keywords, and numeric values, variables, all these things we stored in the symbol table. This symbol table make easier to the compiler by identifying, record, and retrieve it. By using it as a storage, it will store the memory, and it will store all the data which is used in all the phases, and it will we can retrieve and restore all the data which contain in a symbol table. At last, we can say that is we have that is error handler. In these 6 phases, if we are appearing any errors, if we are getting any errors, the error should be stored in the error handler. By using this error handler, it will send the phase by phase. Means whenever it receives any error from the any phase, it sends that error to the next phase to rectify it. So overall, by using these phases of compiler, it is very important in our compiler design. So phases of compiler, again the structure is divided into the 2 phases, that is analysis structure. I am talking about the structure, that is structure of compiler. It is divided into the 2 phases, that is analysis phase and synthesis phase. So this analysis phase we can say as a front-end compiler. The synthesis phase we can say as a back-end compiler. So here it is divided into the two compilers, front end and back end. So here the front end contains the first three phases of compiler, that is lexical analyzer, syntax analyzer and semantic analyzer. Already we discussed what is the use of lexical analyzer, syntax analyzer and semantic analyzer. It will do this work by using these three. It will perform the action in front end compilation. The backend, it contains the intermediate code. Backend, it contains the intermediate code, code optimizer and code generation. So this is get for the 5 marks. The structure of compiler, it is divided into the two phases, that is analysis phase and synthesis phase. So before why we are discussing about the phases of compiler means, first we need to know how many phases we are using in our daily life. After that, the structure of compiler, how it is divided, how many types it is divided. So it is divided into the two types, that is synthesis analysis or synthesis phase. The second one is analysis phase and synthesis phase. This analysis phase is also known as the front-end compiler. Front-end compiler. By using in this front-end compiler, it uses the first three phases in compilation, that is lexical, syntax and semantic. The next one is synthesis phase. It will perform in a back-end compiler, back-end compilation. It uses back-end compilation. These three are the back-end compilers. So these are the very important. The structure of the compiler is very important, and the phases of compiler. They will ask the question as the what explain the phases of compiler or explain the structure of compiler. When they are asking the structure of compiler, first you need to say it is divided into the two types, that is analysis phase and synthesis phase. Again you need to explain all the phases. In analysis phase, the front end, what we are using, what are the phases we are using, and synthesis phase, what are the phases we are using. That thing we need to explain in the 5 marks in the diagrammatical way. So the next intermediate code and the symbol, the thank you.